Hello everyone, welcome to another exciting moment. Class today we're going to be looking at a question that has to do with the strength of a solution. In this calculation, said if a concentrated solution of hydrochloric acid contains 27.1% of hydrochloric acid by mass, and the solution has a density of 1.18 gram per cm cube. Calculate the molarity and the molality of the solution. We have the relative molecular masses of hydrogen and chlorine there. So now, before we go ahead, you know that since we are talking about by mass, and in that mass we have a 37.1% of hydrochloric acid. That means that the solution itself, the mass of solution will then be 100 grams. That means mass of HCl will then be 37.1 gram, since we're talking about by mass. All right, so, and there's something we need to find out here. We need to first get the volume that's involved, because the volume will be needed when we're talking about molality of this. So we'll talk about the volume now. How do we get the volume? To get the volume, we know that density is equal to mass over what? Volume. And we have our density. Our density is what? Our density is 1.118 gram cm cube. That's our density. So, and based on that, I think I should get this thing. Yeah. Okay. All right. Based on that, since density is mass over volume, it then means that volume will be mass over what? Density. That is to say, the mass of the solution. Now we have this, and the density of the solution, which is 1.18. That will give us, if we use our calculator, we will get all right, using our calculator, we then is the answer is what we have here is 75 cm cube. That's the this thing is cm cube. 84.75 cm cube, which is the same thing as 0.08 or we can make approximately this dm cube. That is 0.0848 dm cube. So now we have the volume of the solution. Now we'll go ahead to find the first thing that we are asked to calculate. The first thing, which is the molality of HCl. So in this molality of HCl, we know that molality, I'm not going to do this now. Molality is always molarity is amount over what? Volume. Amount over volume. Now, to get the amount of HCl, the amount of HCl, that is in moles. The amount of HCl in moles to give us the mass. The mass. Remember, the mass is 7.1, and the molar mass. The molar mass, which then be 1 plus 35.5. That will be equal to 36.5. 36.5. All right. So, and we know that molar mass. This is our molar mass, which is 37.5, and we know that amount is always mass over what? Over molar mass. Molar mass. So since amount is mass over molar mass, then what we'll do here is our amount will then be equal to the mass divided by the molar mass. Then what we have here is using our calculator, what we have here is equal to 1.02 moles. 1.02 moles. Then remember, we can then work on this one. We can then get this done. So we have the amount, we have the volume. Since we have the volume, then what we'll do next is perhaps let me write it here. What we'll do next will then be 1 point, that is the amount, over what? Volume. Then when we divide it, dividing it, will have 11.98. That's mole per dm cube. That's for the molarity. Then the next one we're going to work on now is the molarity. Molarity, we're going to, all right. So the next thing we're doing is calculating the molarity. Now we know that molarity is what? Amount in mole over mass of solvents. Now remember, in the solvents, to get the mass of solvents, the mass of solvents will have note the total solution in mass by mass is 100%. Is 100%, and then we were made to understand that the other one, the concentrated acid by mass, is what? Is 37.1. So when we subtract this from the 7.1, what we have, the remaining one, there will be the mass of the solvent. So by doing that, what we have here should be 62.9 grams. 62.9 grams. That's what we have. So the next thing now is that we already know that the mole, that is the amount of hydrochloric acid, is what? 1.02 moles. 1.02 moles from our previous calculation. Now to calculate the molarity, now what we do here, this will be also in kilogram. We convert it to kilo. This is gram. We can then convert to kilogram by dividing. We have, if we divide it, we have by 1, dividing it by 1000, we'll have kilogram. So now the molality will then be by dividing, we have what we have here should be 16.21 mole per kilogram. Alright, thank you so much for being a part of this program. I want you to subscribe, comment and like, and also share so that people will know about it. Thank you so much.